Hello and welcome everyone. In this chapter, we are going to discuss advanced EIGRP concepts. Okay, so we'll try to understand some of the EIGRP terminologies, which is very important since it is all about this. See, we have something known as feasible distance. We have something known as feasible distance, which is FD, and we have advertised distance, we have successor, we have feasible successor. So let us try and understand what exactly this successor, feasible successor, and advertised distance and everything that you have. Okay. Apart from that, one more thing is important along with that is about this one. EIGRP tables. Since EIGRP maintains neighbor table, topology table, and the routing table. So we'll try to understand how exactly it's going to build and what exactly these are. Okay. So let's get started with the same. Say this. So let us consider a scenario here. So say for example, we have a router here and I have another router like this and another routers. And this all the routers are connected to each other like this. Say this. So the very first point is to understand, let's say the router's name is like R1, R2, R3 and R4. So here we have serial 0, serial 1 and like that serial 0, serial 1, serial 0, serial 1 and this is my serial 0, serial 1 and let's say this is your Ethernet 0. And there is some network you have, let's say 20.0.0.0/8 is the network. This is my LAN network which is connected here. I mean here my PCs are connected. Now the major point is to understand about this, that I will consider this router as my source router and this as my destinations. This as my destinations. So let's say what happens if it is source and if it is destination. Of course, couple of major points to remember in this. Okay, so let's see. So as I said, this I will keep as a source and this I will keep as a destination. If you remember in EIGRP, we discussed one of the major point that EIGRP uses the something known as composite matrix as a matrix, and that composite matrix is basically the output of some of the calculation. And this composite matrix are some kind of number you will be getting. Say for example, I am taking the composite matrix here as 100, composite matrix here as 100, here also as 100, here I am taking as let's say 120 and here composite matrix as let's say 10. Okay, now next point. So first of all we need to understand that EIGRP maintains the tables, correct? No, EIGRP maintains the tables. Let's say we have configured the EIGRP in all the routers. Now EIGRP will first go ahead and create one of the entry which is considered as your neighbor table, which is considered as neighbor table. Okay, and I will consider this neighbor table is for my R1 router right now, R1 router itself. Okay, so what kind of entry will be there in this? It will be like, hey, I have two different neighbor. I have R2 and R3 as a neighbor, and R2 is connected with which interface to me? It is connected with serial 0 and serial 1, correct? No, this is my serial 0 and this is my serial 1, correct? This is basically your neighbor table. This is neighbor table which is maintained in router 1. Similarly, your router 2, router 3 and all other routers will maintain the neighbor table. After the neighbor table, routers will go ahead and they will create the another table now, which will be considered as, I will discuss, which will be considered as topology table. Topology table for router 1. Topology table for router 1. Okay. Topology table is all about, once a router has formed the neighbor relationship together, routers will exchange the update. So when the routers are exchanging the update, they will not put that update directly into the routing table. No, they will keep that into some kind of database, and that is considered as topology table. So that's what here the topology table. And router 2 see, this 20 dot network will come to this router 2, will say hey, 20 dot network is here. It will come to this router, it will say hey, 20 dot network is here also. It means to reach this particular 20 dot 0 dot 0 dot 0 slash 8, I have the next hop, means I can reach via R2 router as well as I can reach via R3 router. If I am going via R2 router, what will be the values now? So first of all, you need to understand the values now. See, the distance, see, this is my source. So the distance between source to neighbor router, this is considered as LLD, local link distance. Local link distance. Source to till neighbor is LLD, and neighbor to till destination is considered as AD, advertised distance. Advertised distance. Fine. See in this, even when you go ahead and try to write down, you will find. Fine. So say for example, when it comes to my advertised distance, what will be my advertised distance here? It will be like, hey, this is advertised distance via R2. Tell me, advertised distance via R2, what will be the value? 10 plus 100, it will be 110. Via R2, this will be advertised distance. And after that, you see, from here to here, this is LLD, local link distance, and from here to here, that is considered as AD, advertised distance. So if you go via this, now the advertised distance will be 130, correct? No, 120 plus 10, 130. And now what will be the total value? Total value is about FD, feasible distance. Feasible distance, you know what? Make sure LLD plus AD is equal to FD, feasible distance, not fixed deposit, it is feasible distance. Means you combine this as well as this from source to till destination, considered as FD, feasible distance. That is only your composite metric of your EIGRP. So tell me, from here to here, what is the composite metric? 100 plus 100 plus 10. It is going to be 210. 210. Similarly, when you go via R3, it will be 100 plus 120 plus 10. It will be 230. Now see, we have two different paths available here. Now which path is going to be the best path in this? Right now if you see, via R2 the feasible distance is 210, and via R3 feasible distance is 230. So this router has the less metric, means this will be basically considered as your successor path. Successor in the sense best path. Successor in the sense best path. And this path is also available. Is it going to be second best path? Yes or no? So the answer is yes or no. It is completely depends upon one of the condition, which is called as feasibility conditions, which is called as feasibility conditions. And what is this feasibility condition? Feasibility condition says that your FD and your AD, this is your feasibility condition actually. Your FD has to be always higher than second best path AD. It's like second best path advertised distance, should be less than of your FD, of your successor. Okay, means your FD has to be always higher as compared to AD. So in this case, if you see, the feasibility condition is very simple right now, as my advertised distance of this second best path is 130 and FD is 210 of my successor. So is it less or not? So of course it is less, it is higher, it will be successor. And if it is less, then it will be considered as my feasible successor. Feasible successor in the sense, this is my second best path available into the topology table. Simple. Make sure if they match this feasibility conditions, then only it will become the feasible successor. What happens if the value is something different? Let's say here it is 210 and here it is something like, let's say 400 in this AD 400. So it is higher, correct? No, it is not meeting your feasibility conditions. That means you are not the feasible successor. No more feasible successor if it is 400. But right now in our condition, feasibility condition is matching because 130 is less than 210. Fine. So this is my feasible successor. Fine. Second best path. Now the next table which is created by your routers is you're going to be your routing table. The next table will be routing table for R1. Correct. It's all about only the best path will install into the routing table. Make sure best path in the sense it's all about 20.0.0.0/8 you can reach via next hop, that is R2, and the total feasible distance is 210 and this is going to be my successor path. This is what the value you will find in this. Only best path will get installed into the into the routing table. So that's it. This is what your different table, your table 1, neighbor table, topology table, and routing table. And the terminologies from source to neighbor router is LLD, and neighbor router to till destination is considered as AD, and total AD plus LLD is equal to FD, your feasible successor. Feasible distance. That is your composite metric actually. Also, feasibility condition is all about this. The second best path advertised distance should be less than feasible distance of your successor. It's like 210 and yet here it is 130. So 130 is less than 210, that's where it is feasible successor. If the value is more, let's say 400 in terms of AD here, if it is 400 and it is 210, means it is not matching the feasibility condition. If it is not matching, no feasible successor, only successor path will be there. So topology table is a kind of database table where it contains the successor as well as feasible successor path if feasibility condition matches. But in the routing table, only successor path will be there. So that's it for this particular scenario. Let's come back to our discussion now. See this. As we discussed, our very first thing is this one. Read this. So first of all, read this. Feasible distance. Feasible distance is the metric of your best path to reach the destination, including local link distance and advertised distance. It's all about composite metric to reach the destination. This is my composite metric. What is it? Advertised distance plus LLD. What is advertised distance? Read this. The distance of the routes as advertised by the neighbor. It does not include the local link distance. It's all about router to another router. This is your LLD, and after that to till destination will be considered as AD, advertised distance. Successor. What is successor? The neighbor with best distance to the destination. It's all about less metric will be considered as successor, your best path, and if you have the feasibility condition matching, the routers will also have the second best path as well. That's nothing but the neighbor with second best distance to the destination which meets the feasibility condition, which meet the criteria of feasibility condition. will become the feasible successor. Simple. If they are not meeting that particular conditions, which conditions? Talking about this condition. If they are matching, feasible successor is there. If they are not matching, no feasible successor. Next, EIGRP tables. As we discussed, EIGRP maintains 3 tables. One, you have neighbor table where directly connected networks will be there. Topology table, which contains the entire entry of your all the destination along with feasible distance and advertised distance. Make sure it contains successor as well as feasible successor path if any. Routing table is all about the entries with the best path to reach the destinations from the topology tables or moved into routing tables. So the best path will be into the routing table itself. Simple. So that's it for the table. We do have quick concept for EIGRP router ID. EIGRP router ID. So what exactly it is? See, say for example, let's say you have the multiple routers like this. You have the multiple routers like this connected all together. Some network is here. Let's say this is your router 1, router 2, router 3, router 4, router 5. Now in this scenario, if you see, there is one of the update coming from your R5 LAN interface. Let's say it is my fast Ethernet. So R5 will say, hey, R5 will say that I have a network of 10. Oh, sorry, hold on, my scenario is gone. let me create the scenario again. Just give me a moment. So let's say this was the same scenario, like this router, another router, router, all the routers was connected like this. You have the network here. This is my R5, router 5, router 4, router 3, 2 and 1. So normally your R5 router will advertise that I have this particular network in my environment. Fine. Now the point is, this update will go to all other routers which is connected in this. This update will go to all other routers here. So how other routers will come to know whether who is advertising this particular update? By using this particular R5, correct? No. So this R5 is nothing but it is basically your name of the router, and this name of the router itself is considered as your router ID. Router ID. So router ID is nothing but name of the routers. And normally routers ID is not like just name. No, it's not the name actually. Actually, instead of R5, it will show the IP address, some kind of IP address. So router ID is basically some kind of IP addresses which is identified the specific router in the EIGRP domain, so that you can come to know from where this actually update is coming. That's it. Read this. The router ID is used to identify the routers in EIGRP. And how to configure EIGRP router ID? See, there are some preferences I will discuss, but before that, see here. How to configure EIGRP router ID? It's all about under EIGRP, like router EIGRP, then AS number, then you configure EIGRP router ID command with this syntax. So for example, you can define any IP address here. That's it. This is how you can configure manually. If you remember, in our demo, previous demo, we haven't configured any kind of EIGRP router ID. If you do not configure EIGRP routers ID manually, then what happens? See the preferences for that, very important. If you configure EIGRP router ID, see, the first preference is given to router ID command. If you configure the router ID commands manually, it will choose this as a router ID. What happens if you haven't configured this command? Then routers will go for second preference, where it will check the highest loopback interface configured on the routers. It's all about highest loopback IP address will become the router ID of your routers automatically. Say for example, you have configured loopback 1 and loopback 2. Here loopback 1 has the IP address of 10.0.0.1. Loopback 2 has the IP address of 100.0.0.2. So this is highest 100.0.0.2. It will become the router ID automatically. Similarly, what if you haven't configured loopback also? Maybe loopback is not there in my routers. Then the third preference is given to highest physical IP address. Highest physical IP address. Your routers will take automatically the highest physical IP address and it will make that as a router ID. That's it. So simple term, router ID is basically the name of your router, identifications, it's IP address actually, and the first preference given to router ID command, second preference is given to highest loopback interface IP address, and third preference, if loopback is not configured, then it will go for highest physical IP address. That's it for this particular chapter. We will see you in the next lecture for your demo as well. Thank you. See you in the next.